These are the classwork solutions for May 12th on quadratic functions and their graphs. We have a quadratic function here represented with this parabola. It's a downward facing parabola. And we're asked to find the vertex, the axis of symmetry, the y-intercept, and the x-intercept. So first it's important to realize how the vertex would be where it's turning. If you look here, your values are increasing, and then they start to decrease as I'm going and looking at this from left to right, or as the x values are increasing. As the x values are increasing and going left to right, I'm seeing an increasing of the output values, but then it starts to curve downward. That point where it starts turning is right here. That's your vertex. And we're assuming how, when it's not written, we assume that each of these represents one whole box. That vertex would has an x value of 1, and then we follow it up to see what the y value is. The y value is in between 4 and 5. It's actually looking to be halfway in between. So I'm going to make my y value, or my output value, 4.5, since it's halfway between those. The axis of symmetry always starts, it's a vertical line, and I'm going to use red to represent it. It's this dotted vertical line. And it always starts off with x equals, since it's a vertical line, and x equals 1 in this case. And the vertex will always go through that line. The y-intercept, I'll use pink to represent this, is where the graph is crossing the y-axis, which is right here. And again, it's not exactly on one of the grid marks. It's between 3 and 4. So I'm going to approximate the y-intercept. It has an x of 0, but I'm going to approximate the y value to be 3.5, since it's not exactly on the 3 line or the 4 line. It seems to be more so halfway. And then our x-intercepts is a few other terms that they could use that are synonyms: roots, solutions, zeros. Y would equal 0 at those points, just like x equals 0 at the y-intercept. At the x-intercept, y equals 0. And right here would be one of the roots, and right here would be one of the roots. And again, over here, it's not exactly on the -1 line or the -2 line. It seems like this is being separated into pieces of fourths. So I'm going to make my x value over here -1 and a fourth. -1 and a fourth, or -1.25. I'm approximating here, but it seems to be a fourth of the way past -1 as you move to the left. And if it's needing to be as a coordinate, our y value is 0 here. And the other root, or x-intercept, would be over here, which is past the 3. Again, it doesn't seem to be halfway through. It seems to be more of a fourth after. So I'm going to make that 3 and a fourth, comma 0. Again, y equals 0 at all your x-intercepts. In the next question, we're asked for the axis of symmetry. Again, that's the dotted line that's going to create a reflection over that line, or some symmetry. And right there, I just drew it for you. And it's passing through 2. So the axis of symmetry, we're not going to just write the number 2. If you need the equation, you have to put x equals 2. All vertical lines should be x equals a number. In this case, 2, since that's where the dotted line goes through. They also only asked about the axis of symmetry here, not the vertex. Question 6. In here, they want both the axis of symmetry and the vertex. first we want to find the axis of symmetry. It would be the vertex is right here. The axis of symmetry would be this dotted vertical line going through it. No labels were given, so it's assumed that each of them is 1. So this would be -1, -2. So x equals -2 is your axis of symmetry. Again, x equals is how you start all vertical lines, and then you put the number it goes through, the integer. And then the vertex would have that same x value. So the x value is going to be -2, and then we're going to have to find out where the y value is. 1, 2, 3, 4, 5, 6. Therefore, x equals -2, and then the vertex is -2, comma 6, choice 4. Whenever you have y equals, some of these have y equals, those would be horizontal lines. We look for the vertical line of axis symmetry. They start with x equals. In question 7, they're not interested in the vertex or the axis of symmetry, they're interested in the roots. So we're going to go ahead and see where does this upward facing parabola hit into the x-axis, and that would happen at -6 and 3. Choice 3. And then the last classwork one, a ball is thrown into the air from the, so right here, the time, this x-axis usually always represents the time, and your y-axis in this case is going to represent the height of the ball. A ball is thrown into the air from a 48-foot high cliff. So the ball is at the location of the cliff here, 48 feet above the ground, and it's thrown, and it could be modeled with this quadratic function and a parabola. It's going to reach its max height right about here. This is going to be the max height of the ball. Then it's going to start dropping down to the ground. And it says for which interval is the ball's height always going to be decreasing. Right here it's increasing, and then from here to here it's always decreasing. So from the moment that it has the max line down to when it hits the ground, it's going to be a decreasing height. Right here is the timing of when it hits the max height, and that's going to be 2.5 since it's the box in between 2 and 3. And over here when it hits the ground, it's going to hit the ground at 5.5 seconds. Therefore, choice 3 represents the timing x when it's greater than 2.5 when it reaches its max, and has to be less than when it reaches the ground, which would be the timing of 5.5.